I have three great guests with me today, and we've already met Blessing, but maybe you could introduce yourself, Blessing?
Hi, thank you, David. I'm Blessing Omokobayama, and I'm from the University of Lagos in Nigeria.
Okay, fantastic. And Kellen?
Yeah, I'm Karen Sumwiza. I'm from University of Rwanda, from Rwanda.
Okay, and we
Yes.
have Pega with us as well.
Yes, my name is Pega. I'm working as a postdoc researcher in Uppsala University.
Fantastic. So we decided that we'd start our lessons with regression. And Blessing, you've been through some of the mathematics behind regression, but I know that you also use it in your research. Could you tell me a little bit about the research questions you're working on?
Thank you, David. I am working on finance, but basically looking at credit risk management in finance. It has to do with loaning companies and microfinance banks or any business that extend loan to customers. And yes, I tried to apply linear regression in this particular research because since linear regression has to do with predicting the outcome of a variable using either a related variable or known variable.
And what's the variables in your case then? What would be a variable?
Yeah, variables are like features. Features. That's when we talk about the independent variable and the dependent variable. So in this case, our dependent variable is our target.
Okay.
What we're trying to predict.
Okay, and that is if people are going to pay back the loans you've given them?
Yeah, exactly. So we're trying to predict if certain customers who have taken loan are going to be able to pay back or not. So in this case, the target variable is called the default.
Okay.
So we're calling either they will default
or... The default is not managing to pay back your loan.
Exactly.
Okay. So you want to avoid giving loans to people who are going to default.
Exactly.
And what sort of variables do you put in to predict that then? Yeah. Your independent variables.
Yeah, for the independent variables, we try to look at certain features as regards the customers. We try to look at the credit score. We try to look at payment history. We try to look at employment status. We try to look at something called debt to income ratio.
Okay.
Yeah, so we look at marital status.
Okay.
We try to look at inflow. That's the source of income, the inflow and the outflow. Try to look at the relationships surrounding these things to see if...
So there's lots of variables that go into those
lots of variables. You just look at them. That's where the linear regression comes in. So we try to see which of these features would have a high predictive power in order to be able to predict if it's going to be default or not.
Yeah, fantastic.
Yeah. Thank you.
And Kellen, you work in a very different area using the same types of methods. Could you tell me a little bit about what you work on?
Okay, good. I'm working on cardiovascular disease, which are heart diseases, heart problems, and there are so many diseases. But specifically, we are working on atrial fibrillation. We are trying to look at the existence of atrial fibrillation depending on some kind of independent predictors. And we have tried to apply logistic regression. It was found as a very easy statistical model, which can look at the relationship between the outcomes and the dependent
And what's your outcomes in your case?
The outcome is atrial fibrillation.
Okay.
And the predictors...
So this is if they have the medical problem in the future or not? Yes.
Yes. Yeah.
And then your independent variable, what's that?
The independent variables are age, there is sex, there is history background, there is hypertension, diabetes, and some different medications.
Okay.
Then we are trying to see which of those are highly predictors of that atrial fibrillation disease.
And you told me before that you also use an ECG reading in these predictions. So so people go and do an ECG and then you give them a prediction about future medical health and so on.
Yes, yeah. ECG was used as a device to take collection of those kind of different informations, heart disease informations, like how the heart disease beats, like that atrial fibrillation, to see if there is any irregularity. And also, it was used to capture some of the heart rate, like if the heart beats either high, that is a sinus fibrillation, and to try to detect how the heart functions. It's like that ECG was used as a device to capture the information.
Wow, so you're using this to save lives, essentially.
Yeah.
Wow, that's fantastic.
Good.
And Pega, you work on a very different area. You're not really saving lives. What do you work on? Do regression models for?
Actually, I'm saving the life of the coaches, maybe, or video analyst. I'm working on a football area, working with the football data, and I'm trying to, for example, give some kind of recommendation to the shot quality and the other aspects of the game.
Okay, so you work with a model, it's called the expected goals model. Could you say a little bit about what that is and how that relates to regression?
Exactly. I'm using linear logistic regression basically to measure the quality of the shots, in which I can measure some kind of probability that what is the probability of a shot to result in a goal, in which 1 means 100% of resulting to a goal, which never happens, and 0 means no chance of resulting to a goal.
Okay.
And given that we can measure the shot quality and the quality of the player to put himself into that situation.
Okay. And what would be the independent variable in that case, the variable that you use to make the prediction, or the feature, as you might call it?
It's basically some kind of our daily task that we are deciding to put into our model. But what we are commonly putting on the model is about location of the ball holder, and also some distance and angle from the goal, and also some defensive measure with regard to the positioning of the opponent team in front of the ball holder.
So how many defenders are near to the player when they take the shot?
Exactly.
Yeah, okay, fascinating. So there's all sorts of different applications for regression, and we decided to start this course with regression models. Could you tell me a bit, Blessing, why it's important that we learn regression first when we're starting courses on machine learning and artificial intelligence?
I'll say we start with regression model courses because in order to build models in trying to solve a particular problem, we need to have an insight of what exactly it is we're looking for. And then regression comes in where it tends to find a relationship between certain variables and how they interact with each other, and how we can use that to predict, or rather to build a model. If it's a prediction model, if it's a classification model, regression comes in, like we have the linear regression or the logistic regression that has to do with binary classification. So regression model in this case, I see it as one step to know in building models when it comes to prediction or classification, understanding the features surrounding those.
So you can both understand, you can make predictions about what will happen in the future, like if someone will default from their loan.
Of course,
but
yes,
you can
certainly.
also start to understand the problem better.
Better, exactly. Understanding the features, the relationship around having that, trying to know which of these variables or the features have a strong correlation, giving us an insight on if this is going to lead to a default or not.
Exactly.
So
and Kellen, you've mentioned, and you also said this too, Blessing, logistic and linear regression. Could you explain a little bit about the difference between logistic and linear regression? We've learned about linear regression so far, but what is logistic regression?
Okay, logistic regression, it's a model. It's a kind of model, but it is under the linear regression. So for it works on and why it makes it important. It is a simple model. It works on probability of looking at the outcomes, and those outcomes should be binary.
Okay, so it's a binary thing. Instead of like a continuous variable, you have a binary outcome, 1 or 0.
Yeah, 1 or 0, meaning that if maybe what you're predicting is existing, it takes 1, and if it is not existing, it takes 2.
Okay.
So it's like now it is simple and easy to apply maybe for the beginners if you want to start running the models. models around, and it can also work on that side of predicting if something exists, depending on some given information as predictors.
Okay, and that's also why you talk about logistic regression, Pego, because you've got a 1 is a goal, a binary outcome, 1 a goal, fans are happy, 0 a miss, fans aren't so happy. That's the same type of problem.
Exactly.
Okay. And you also, I know that you don't just use linear regression or logistic regression, but you use more advanced, or maybe, I don't know if more advanced, but different AI techniques. Could you say a little bit about the types of things you would learn after you've learned linear regression and logistic regression?
But basically, I need to first say that why I'm using the regression models. First of all, because I want to consider some kind of like why this, what was the situation that goalkeeper or that ball holder was inside.
So this
to
goes
understand
back to what Blessing said about it being understandable and easy to interpret. That's the advantage.
Yes, of the logistic regression. But when it comes to like some kind of neural networks, we cannot. We need to like just feed the whole raw data to the model, and we are not able to provide some kind of interpretation of how much is the distance and angle. That's a task of neural network to consider.
So it's
those.
More of a sort of black box. You sometimes talk about that. You can put things in, and there's maybe less understanding immediately from that.
Exactly.
Okay, that's fascinating. Now, I want you to know, you've talked a lot about how you three work with different applications. Can you tell me a little bit about when you talk to the people, when you talk to a bank, for example, Blessing, what do they feel? Do they get something back from the types of models you've constructed?
Yeah, it's still under progress.
Okay.
It's still a work under progress. So
it's a little bit of convincing sometimes.
Yeah, definitely. So it's still a work under progress, and approaching the bank and telling them, okay, it's already an existing problem, and okay, yes, we could do something that can bring up a solution to the long-term problem. So we're still working on it.
Okay.
And hopefully it will go global.
And how about you, Kellen? Are you still working on it, or is there some immediate impact of the research that you're doing?
It is part of the research I'm doing and still working on, but expecting to build those decision-making models. It's like in case if I'm done, I can just go tell them how good it works.
Okay.
Then maybe it can help them to make decisions, especially maybe for those doctors that have no much skills on interpreting some information. It can help in that way, but it is still under work.
And how do football coaches respond when they hear about your models?
It's totally dependent on the coach, but in my field, maybe the accuracy and some kind of accuracy metrics such as confusion metrics are not very much important.
Okay.
Instead, we need the coaches and in the football industry people, actually video analysts and others, to validate our models to see if we are giving them some good suggestion or not.
Do they believe you when you tell them the expected goals of a shot? Do they think that it's a relevant statistic to listen to?
As I mentioned, it's totally dependent on the coach. Yeah, if they are a fan of mathematics, they're happy to listen and digest that. They will definitely like it. Yes.
Fantastic.
It matches their line of thoughts.
Okay. Very good. So I have one final question, and this is the first lecture or the first part of the course we've had in order to getting ready for doing a PhD in AI. Could you tell me a little bit about, could you say for the students who might be watching this, why it's important that they learn linear regression?
Yeah, thank you, David. Like I said earlier, it's important for them to learn linear regression for a start, because they'll be handling various data. They'll be coming across various problems, and they need to build models, find solutions. So linear regression for a start will help them understand how to work with various data and get the targets, the independent variables, dependent variables, understand the features surrounding this, the data that we'll be working with, and getting insights from those data. So I think linear regression for a start will help them work with those data and build predictive models, right? And then they can take it a step forward from there.
And you went through a lot to do with minimization.
Yeah, minimization.
Because that really comes out later, doesn't it? When you're trying to use a neural network, as Pega was talking about, you also need to minimize some function in order to fit that.
To fit that, because they need to start trying to understand a particular problem. You need to start from, let me say, the grassroots. So having an understanding from the foundation, it gives them that knowledge on how to move forward to other types of algorithms, other type of machine learning methods, especially when they face thousands of data, because certain machine learning algorithms might not be able to fit into the data they might be coming with. But when they start with linear regression, for instance, they have an understanding of how to work with data. Then they begin to move forward into other types of machine learning algorithms. Yeah.
And Kellen, what would you say to a student who's maybe, okay, I've watched this video. Do I really want to get into linear regression? How would you motivate them to get going?
Yeah, it's not different from what Blessing has said. Of course, if you're entering to the area of AI, what you need to work on is data. So given data, you need to know how to analyze, to link the independent and dependent. So in this case, linear regression will help them to learn that relationship. Once they are having the available predictors and they are having the dependent variable, they will be able to learn how those different variables depend or relate to each other. So this linear regression will help them as the startup. It's a simple model. It will just teach them how to link those. Then they get to understand that area of how to deal with data.
Okay, fantastic. And Pega, do you have some thoughts on why you might want to learn this linear regression to start with?
Yes, definitely. So I really suggest that everyone who wants to start in this topic, whenever they want to do some kind of model that is dependent on some contextual features. For example, in my case, before introducing the expected goal, people were just using some maybe shot success ratio, which is the ratio of the goal shot resulting to a goal, but it doesn't show that how much what was the situation that the player exactly what was the situation that the player was inside, and doesn't give the context. If they want to consider this kind of contextual measures, they should definitely start with first regression and then going for more advanced regression models.
And it's also the case that you work in 3 completely different areas, which are all really important for society: finance, medicine, football. Everyone loves football.
Everyone.
Well, lots of people do. I mean, these are really important areas of society. I don't know if you have any comment on that, Blessing. I mean, you said when we talked and we did the introduction, you said that this is all of these things. If we can learn these methods, it's really important to development and sustainable development in Africa. True. I mean, can you link a bit back to that?
Okay, based on my research work or just generally?
Well, in general, if we can increase these skills, what kind of effect do we expect in the end?
I want to believe that every day, day in, day out, there is a need for improvement. There is need for development. There's need for growth. And how do we make this come into fusion? It's by identifying certain problems, find a solution to those problems. Now, how do we find solution to those problems? It's by making use of methods that will bring solutions quickly, effectively, accurately, and then this machine learning methods comes in.
Okay.
Yeah. So by the time we apply machine learning methods in solving problems, I think they will give us a better outcome.
Okay.
Let's put it that way. Yes.
Fantastic. I think that's a really nice note to leave on it. Thank you, all of you, for talking to me about your work.
Thank you, David.
Thank you.
For having us. Thank you so much.